Hi everyone, so today I'll be discussing to you, or in this video rather, a comprehensive report on the application of the Laplace transforms in thermal engineering. So for the content of this video, we have an introduction to Laplace transforms, a refresher on Laplace transforms. We also have the application in thermal engineering, solving the transient heat conduction problems, and additional information. And lastly, our conclusion of Laplace transform in thermal engineering in this video. So, introduction. Laplace transforms are fundamental mathematical tools widely employed in engineering disciplines for solving differential equations and analyzing dynamic systems. This report aims to provide a comprehensive overview of the application of Laplace transforms in various engineering fields, including a refresher on what Laplace transforms are, how they are utilized in engineering applications, and additional information that might be useful for practitioners. So, first and foremost, let's get a refresher on Laplace transforms. So, Laplace transforms is a mathematical operation that converts a function of time into a function of complex frequency domain. It is defined by the integral of where f of s is the Laplace transform function f of t and s of s is the complex frequency parameter. The Laplace transform is particularly useful for solving linear ordinary and partial differential equations with initial conditions. So, application in thermal engineering. In thermal engineering, Laplace transforms are applied to analyze transient heat conduction, convection, and radiation problems. These problems often include complex geometries and boundary conditions, making analytical solutions challenging to obtain directly. By employing Laplace transforms, engineers can transform the governing partial differential equations into algebraic equations in the Laplace domain, which are easier to solve. The solutions obtained in the Laplace domain can then be inverse transformed back to the time domain to obtain the transient response of the thermal system. One example would be solving transient heat conduction problems. So, in transient heat conduction occurs when the temperature distribution within a solid object with time due to variations in boundary conditions or internal heat generation. Laplace transforms are used to solve the transient heat conduction equation, such as one-dimensional heat conduction equation, where you can see here that where T is the temperature, X is the spatial coordinate, and time and alpha is the thermal diffusivity. By taking the Laplace transform of both sides of the equation with respect to time, engineers can obtain an algebraic equation in the Laplace domain, which can be solved for the Laplace transform of the temperature distribution. The inverse Laplace transform of the solution yields the temperature distribution as a function of space and time. Additional information of Laplace transform in thermal engineering. In addition to transient heat conduction, Laplace transforms are also used in thermal engineering for solving problems involving transient convection and radiation. For example, Laplace transforms can be applied to analyze transient behaviors of heat exchangers, thermal uh, orange systems, and transient heat transfers in composite materials. Furthermore, Laplace transforms facilitate the analysis of systems with non-constant boundaries of time-varying heat sources, providing valuable insights into the dynamic behavior of thermal systems. In conclusion, Laplace transforms are indispensable tools in thermal engineering for solving transient heat conduction, convection, and radiation problems. By transforming the governing equations into the Laplace domain, engineers can obtain an analytical solution to complex thermal problems and gain a deeper understanding of transient heat transfer phenomena. The versatility and the efficiency of Laplace transforms makes them essential for modeling and analyzing thermal systems in various engineering applications. Thank you so much for watching this video. I hope you will like and subscribe. Thank you.